we are getting some practice writing equations with numbers and variables. So we have a scenario here where we're going to imagine we are riding horseback. We've gone out to some dude ranch in Wyoming or something like that, and we're going to ride horsies. So we have 3 plans we can choose from, and one is where you can ride all day for $75. All right. The other is where with a $33 sort of registration fee, you can then pay $7 per hour thereafter. The other one is just a flat rate of $18 per hour. Actually, I should call this is really the flat rate at 75 bucks. This is the hourly rate at $18 per hour. All right, so we're going to write, using mathematical symbols, a representation of each one of those statements. So we'll say C is the cost of horseback riding, and I'll stay color-coded here. So I can ride all day for 75 bucks, no matter if it's 5 minutes or 15 hours of daylight. So the cost here is equal to 75 no matter what. All right. Here, however, it's a little bit more complicated. Here, my cost is going to be a $33 origination fee, and then plus $7 for every hour. So if I'm riding 1 hour, it'll be 7, 2 hours will be 14, pretty straightforward. This is where we're multiplying the number of hours times 7. We're not adding 7, we're multiplying 7 times H, we'll call that, for the hours that I ride. All right. The third plan is our straight up hourly rate. So for that one, I'm going to say my cost is simply $18 times every hour I ride. All right. So these are just very simple examples of equations that use numbers and variables. The interesting thing here is that you might want to decide which plan you're going to use. Okay. So I think you can see pretty quickly that once we've got equations written, we're going to naturally want to go into graphing them. So very, very quickly, I'm going to just sketch a graph here. And if our maximum amount is going to be 75 bucks, maybe that's 100, there's 50, and so there's 75. So my A plan here, I'll keep it red, my A plan is going to be right there at $75. All right? There's 50, and there's 10, 20, 30, and 40, so I can be a little bit more accurate about my next plan. Plan B is $33 plus going up 7 bucks. All right, so there's 33, and it's going up so that if I'm 10 hours later, that might be a good way to do it. So there's 5, there's 10, oops, not very good, there's 10, and there's 15 if I need to go that far. But at 10 hours, that's going to be $70 plus 33, that's going to be 103. So I know I'm going to be about up there after 10 hours. So that gives me a pretty accurate amount, or line I should say. And then the final option is $18 per hour. Well, if I ride 0, I will not have to pay anything. If I ride 5 hours, 5 times 18 is going to be 90. So I'll be up around here after 5 hours. So this graph is going to look like this. Okay? So you can see that in the beginning, up until I get somewhere about there, this is going to be the cheapest plan. This is the lowest line I can find. And then between here and here, this plan B is going to be cheaper. This is plan C. And then finally, plan A is going to be the cheapest out here. And you'll see that later what we're going to be interested in is finding the exact points, all right, the exact points where the turnaround happens. If you take graph paper and go very carefully, you can do it, or you can use your calculator. And these skills are going to lead into our next section. So see you there.